Today's lesson is about chi-square test of independence. There are two types of chi-squared test. One is a chi-squared GOF test. The other is a chi-squared independence test. Chi-squared independent test checks whether two variables are associated to or independent of each other. HO always the two variables are independent of each other. H1 always the two variables are dependent on each other. For both chi-squared tests, make sure expected frequency greater than or equal to 5. Otherwise, regroup the data. The degree of the freedom for independence test is R-1 times C-1, R for rows, C for columns. Then we need to put the data into the matrix. Conclusion. For chi-squared test, rejection region always on the right side. In other words, chi-squared test is a right-tailed test. So, when chi-square greater than critical value k, reject HO. If chi-square less than k, fail to reject HO. In chi-squared test, make sure all the expected frequency is no less than 5. Otherwise, you need to combine the expected frequency. Then the degree of freedom will change too. Given table, we need to combine these two data together because this expected frequency less than 5. So we get the combined table 16. Adding these two together 13. 16.8. Adding 7.2 plus 4.7 together equals 11.9. Let's go to guided practice 3. A math teacher in school A claims that the comparison between the two schools is not valid because the sample for school B contained mainly girls and that for school A mainly boys. She believes that girls are likely to show a greater improvement from their predicted points P to their final points F. She collects more data from other schools, asking them to class their results into 4 categories as shown in the following table. A. Use an appropriate test to determine whether showing an improvement is independent of gender at the 5% significance level. Let's write down HO, H1 first. HO. An improvement is independent of gender. H1. An improvement is dependent on gender. Then we need to put this into matrix to check expected frequency. Go to menu, go to 7, create matrix. Number of rows 2. Then columns 4, enter, then type in the data. Then we will store this matrix into A. Control variable A, enter. So every time we type A, we got this matrix. Go to menu, 6, go to 7, stat tests, go to 8, chi-square two-way test, right arrow button, A, enter. We got this result. Then go back to these variables. Get this expected matrix. Enter, enter. Then you need to check whether the value less than 5, 4.5, 4.5. We need to combine this together. Second step, regroup the first two columns because their expected values are less than 5. We add 6, 8 together, 14. 3 plus 8 together equals 11. So we got this new observed frequency table. Use this table to get chi-squared value, p-value. Let's go to calculator. Click menu, go to matrix, create matrix. We have 2 rows, 3 columns. Then enter. Type in the data. Then this time, store this matrix into B, then enter. If you put B, you got this matrix. Go to menu, go to 6, 7, stat tests, go to chi-square two-way test, 8. Observed matrix is B. Then enter. We got chi-square equals 1.09. P-value equals 0.581. Degree of freedom equals 2. Variable. Expected matrix. You could see none of the values is less than 5. Then we can draw the conclusion. Since 0.581 greater than 0.05, fail to reject HO. Enough evidence to suggest that an improvement is independent of the gender. Let's go to B. Suggest 2 ways in which you might choose your samples to improve the validity of the test. First of all, we can increase the sample size. Second, we can select the boys and girls of similar ability.